Welcome to qnawire.
So, section 21, question 2, asks us to determine whether these two nickel complexes are either tetrahedral or square planar, given that complex 1 is paramagnetic and complex 2 is diamagnetic. So the first thing that we need to determine in this question is how many electrons do the nickel atoms have. In order to determine this, we need to determine their oxidation state. And in order to determine the oxidation state, we need to first look at the ligands. So in complex 1, we can see that the NH3 ligands, they have a net charge of 0, and therefore, because this overall complex has a charge of +2, we know that the nickel must be in the +2 oxidation state. Now, nickel is a D10 metal at the 0 oxidation state, and therefore nickel in the +2 oxidation state must be a D8. We can use similar logic with complex 2, which has these thiocyanate ligands. These ligands have a -1 charge associated with them, and therefore these ligands actually have a -4 overall charge for this complex. Therefore, in order to get this -2 charge for the entire complex, nickel, again, must be in the +2 oxidation state. So this is for both complex 1 and complex 2. So now that we know that, we have to determine whether they are tetrahedral or square planar geometries. So to do this, we need to look at the splitting pattern of the d orbitals. Now for tetrahedral, this splitting pattern is the following. So if we plug in 8 electrons into this, we can see that it is a paramagnetic species. And since we know that complex 1 is paramagnetic, we know that complex 1 must be tetrahedral. So it's tetrahedral. Therefore, complex 2 must be square planar, but in order to prove this, we can also look at the splitting pattern for a square planar complex, which is the following. So again, if we plug in 8 electrons into this splitting pattern, we can see that this is indeed a diamagnetic species, and therefore complex 2 is square planar.